So what I tried to do, and Kathy brings up a good point, I did it kind of in error a little bit. We'll mention that in a minute. I went in there and circled all the ways. We had 5 in a row, 4 in a row, 3 in a row, 2 in a row, and then I guess 1 in a row. 1 in a row. I didn't circle 1 in a row because we didn't have to bother. I did goof up a little bit in the turning the corner ones. Because technically speaking, we were going left to right and up down. So that last tail on the first row should be paired up as a 2 with this tail on this row. That should be a 2. And then the next row ends with H. This row begins with H. That should also be a 2. Next row ends with tails, start with tails, that should be a 2. And then it looks like H, H, H should actually be a 3. So we pick up 3 more 2s and 1 more 3. I'm feeling pretty good about your guys' randomness, especially compared to the TI, and why is that? Why is that? What's your gut feeling? How much have I circled on the board? Quite a bit of it, yes? Quite a bit of it. And if you compare it to the Excel stuff, it seems to be roughly in the same percentages as Excel. In other words, there's a lot of little 2s scattered throughout each Excel result. Let me pull this down so you can see a little better. There's quite often a lot of little 2s scattered throughout. And fewer 3s, fewer 4s, and the long runs on average seem to be smoothing out quite a bit, right? They seem to be smoothing out quite a bit. So what's happening is I'm going to go ahead and I'm going to blank this guy out. But I'm going to put my stapler on it, let it run for a while. See what that thing looks like in a few moments. It shouldn't. If it does, I'll be pretty stoked, actually. Of course, it has its button right in the way. Oh. Come on now. Let's see what I'm doing. The trick is not hitting the other buttons, and there's this stupid little... Oh, there we go. Perfect. Let him do his thing. So, now, this is not a very good argument as far as it's random enough, because we haven't actually quantified if it looks random or not. We haven't counted anything yet, other than just looking at the TI versus looking at us. I can arguably say you guys look pretty close to the TI. You've got roughly the same number of occurrences of the 3s and the 2s and the 1s and the 5s. I mean, if you look at it, the TI generated a couple runs of 5s, so did you. The TI generated 1, 2, 3, 4, 5 groups of 4. 4. You guys generated 4 of them. It's about the same. The TI generated 1, 2, if I count that correctly. 1, 2, 3, 4, 5, 6, 7, 8. 8 runs of 3. You guys generated 1, 2, 3, 4, 5, 6. You're off by a couple. These are all pretty close. Pretty close. We'll talk about what close enough means as we go through this course together, because that is defining whether or not something's equal versus close enough to be equal is a statistical question. So it looks like you're. How about 2s? How we do on 2s? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You got 16 groups of 2. The TI did 2, 3, 4, 5. If I count that one correct. 6, 7, 8. 9, 10, 11. It did 11. Again, both of you guys are going up as the numbers get smaller, which you're predictably acting pretty random, which is actually pretty slick. I was expecting a much, much larger difference, and you guys didn't demonstrate that, which is pretty super cool. So here's what I want to do now. I want to try to get a working definition of what random means. So what does random mean? The chaos one I like, but I want to get away from pure chaos because it really isn't chaos. You know what's going to happen, you just don't know exactly when it's going to happen. So what does randomness mean at this point in the game, if you had to get a good working mathematical definition for what random meant? Let's get it verbal for right now. In respect with flipping a coin. Flipping a coin, deciding what's going to happen next. What makes that hard?
It's unreliable.
It's unreliable in what way?
You just don't know.
You don't, but you do know.
I mean,
either heads or tails.
You know it's going to be heads or tails, but you don't know which one.
You don't know which one. Let's go with that. Jeremiah, go.
It's like an unpredictable result, not depending on the previous.
Good! That's huge. Doesn't depend on previous results. That's why I was curious to see how your guys compare to the TI. Because you guys admittedly said that some of you were looking at the previous results before deciding what to go. Now what's cool about that is even though you were doing that, you guys still generated some 5s in a row. But I wonder if the ones that generated those 5s in a row weren't the ones looking at the ones coming before. That'd be an interesting thing to go back and correlate what you guys were looking at based on how many we saw in a row. I wonder if the ones that admitted to looking at what came before are responsible for the quick turnovers. I don't know, possibly, potentially. Here's the next question. Let's change it. So a working definition of randomness right now is some unpredictability. I like that very much. Unpredictability is definitely random. We don't know what's going to happen. We might know within what framework it's going to happen. It might be, for example, within heads or tails, or 1 through 6 on a die, or clubs, diamonds, hearts, spades, or deck cards. So you've got a constraint and you know what the outcomes are, but you don't know which one is going to come at any given time. Do you know something more about the coin? There is something more you know about the coin you guys haven't mentioned yet. What do you know about the coin? You mentioned it earlier, you haven't mentioned it in the defining of randomness yet. You know what's going to happen over time. Over time, what's going to happen? Right, they're going to even out. Half the time you're going to get heads, and half the time you're going to get tails. So that's going to happen. That has to happen, assuming the coin is fair. So compare and contrast that. You know what's going to happen over time. Half the time you're going to get heads, half the time you're going to get tails. But you don't know when you're going to get heads and tails. Just over time, the overriding proportion, that's what we're going to let generate right now. We'll pull that back up momentarily after you guys do the next experiment. Fair enough? Good, good. So let's keep those 3 principles ahead of us now as we do our next experiment. What I want to do now is I want to collect some data, and I kind of want to leave this on the board. I want to refer back to it, maybe. I'll collect it over on that window over there. You're going to use your TIs like a coin again. You're going to use your TIs like a coin because I didn't bring coins. So we'll use it as a coin. And here's what we're going to do. We're going to simulate the next experiment, which is going to be the number of times, let's shut this down,